Hello students, welcome to the classroom point. In today's session we shall discuss the objective questions of the periodic table or classification of elements. So the very first question here given is, first question, the IP1, IP2, IP3, IP4 and IP5 of an element are 7.1, 14.3, 34.5, 46.8, 162.2 electron volts respectively. The element is likely to be. So in this ionization potential values, if we see clearly, first ionization potential value is 7.1, second ionization potential value is 14.3. These are close to each other. First of all, I will write down these values: 7.1, 14.3, 34.5, 46.8, 162.2 electron volts. These are all, and this is the first ionization potential, second ionization potential, third ionization potential, fourth ionization potential and fifth ionization potential. Now when you observe these values though they are double but close to each other. But in this particular case, there is a sudden jump in these values. Afterwards, again these two values are close to each other. Again, there is a sudden jump in this value. So what does it mean? It means that these two, first electron and second electron, are present in the same orbital, and these are present in the next orbital, and this is of the next orbital. So means orbital change. When orbital changes, automatically ionization potential values suddenly jumps. So it means that two electrons in the same orbital and these two electrons in the same orbital, means particularly this particular element is having the 4 electrons in there, its valency shell. Now let us see the elements given here. For example, if you take this sodium, atomic number 11, electronic configuration is 1s2, 2s2, 2p6, 3s1. So after the removal of this electron, there will be a sudden jump in the ionization potential value, and moreover sodium is having only 1 electron in the last orbit, but according to this one it is having the 2 electrons. So option A is incorrect. Now let us take this silicon, whose atomic number is 14, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p2. Now you can see here 2 electrons in one orbital. After the removal of these 2 electrons, there is a little bit jump in the ionization potential values, and there also again they are close to each other. Again 2 electrons are in the next orbital. So after the removal of these 4, again there is a sudden jump for the 5th electron. Means the particular element is having the 4 valence electrons in its valence shell. So that is the silicon. So option B is correct. Let us solve the question number 2. Which of the following relation is correct? So we have one relation which relates the ionization potential, electron affinity and electronegativity. The formula is electronegativity is equals to ionization potential plus electron affinity divided by 2. Means it is the mean of both of these values, electronegativity. So we can rearrange this equation as 2 into electronegativity equals to ionization potential plus electron affinity. Now bring both of these also this side of the electronegativity. So we will get the minus ionization potential minus electron affinity is equals to 0. So which stands for the option C. Let us try to solve the question number 3. Palladium has exceptional valence shell electronic configuration of 4d10 5s0. It is the member of. So they said that this is an exceptional electronic configuration. So if you write down the original electronic configuration of the palladium, it will be krypton, whose atomic number is 36, then it is 4d8, then it is equals to 5s2 electronic configuration. So in this particular one, the last one says that orbit number, n equals to 5. So this is the period. Okay. Then if you want the group means always number of s electrons plus n minus 1 d electrons. So how many s electrons are here? 2 s electrons are there, and number of d electrons are 8. Total is equals to 10th group. So it is present in the 5th period and 10th group. Hence option A is correct. If you want to know how to write down the valence shell electronic configuration of a particular element, there was one video which I made already, how to write down the electronic configuration. You can search in our playlist just to find out and try to understand the how to write down the electronic configuration by watching that video. Now let us solve the question number 4. So in question number 4, the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p4. The atomic number of the element present just below of this element in the periodic table is. So we must understand the magic numbers that, for example, if we take the first group elements, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So if you want to get the atomic number of the next element from the first element, it must be have to follow this particular pattern: 2, 8, 8, 18, 18, 32. Means if the atomic number of the hydrogen is 1, that we know that, to which if you add 2, you will get the atomic number of the next element 3, that is of lithium. And add 8 to this 3, you will get the 11. And add 8 to this 11, you will get the 19 and so on. So in this way, you will get the atomic number. So this is of the first period, this is of the second period, this is of the third period, and this element is of the fourth period, and this is fifth period. In the case of this one, sixth period, this is the seventh period. This is possible only in the case of the S block element. In the case of the P block elements, the pattern is different. In the P block elements, the first element is always belongs to the second period, and next element belongs to the third period, and like this fourth period, fifth period and so on. Okay, but the magic number is you have to follow 8, 18, 18, 32 pattern to get the atomic number of the next element. See, here they said already it is the third period. So third period some element is there, its atomic number is completely given as 16. So to this 16, if we add 18, you will get the next element atomic number. So 18 plus 16 is equals to 34. Hence option B is correct. Now let's solve the question number 5. Calculate the energy needed to convert 3 moles they are asking, of sodium atoms in gaseous state to sodium ions. The ionization energy of sodium is 495 kilojoules per mole. So 1 mole sodium needs how much amount of energy? 495 kilojoules of energy. Then 3 moles of sodium needs how much amount of energy? That means 3 into 495 kilojoules. So if you multiply everything this one, you will get the 1485 kilojoules of energy. Hence option A is correct. Let us solve the question number 6. The paramagnetic species among the following is. So they are asking the paramagnetic one. See, if any paired electrons are there. If paired electrons are there means the element or ion is diamagnetic in nature. If at least one unpaired electron is there, then that particular element or ion shows the paramagnetic nature. Now let us try to see the electronic configuration of these elements. Here Na plus is given. Na plus is having only 10 electrons, not the 11. So 1s2, 2s2, 2p6, all are the paired electrons. Next one is Zn plus 2. So Zn plus 2 is having the 28 electrons. So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Here also all are paired electrons. And let us take this U plus. I am not writing the atomic number, I am writing the only electrons present here. So do not misunderstand. And a copper actually 29 atomic number, lost 1 electron, so that 28 electrons I am writing here. So its electronic configuration now becomes 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Now, if you take the Fe plus 3, iron atomic number is 26, so it lost 3 electrons. Now 23 electrons are still present. So electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. You can see the last orbital is completely filled in first 3 cases. But in this case it is not completely filled, only half filled. So you can put the electrons like this. Means all are unpaired electrons are there. So that iron Fe plus 3 is a paramagnetic in nature. Let us solve the question number 7. The correct decreasing order of atomic size among the following species is argon, K plus, Cl minus, S minus 2, Ca plus 2 is given. So here the notable point is in isoelectronic ions, the atomic size or ionic size decreases as Z by E ratio increases. Here Z means atomic number, E means number of electrons. So let us take the Z by E values of all these, and afterwards I will tell one more trick also. So argon atomic number is 18 and it is having 18 electrons. So 18 by 18 it is having. Next one is K plus is mentioned. So K plus atomic number is 19, but it lost 1 electron, so that 18 electrons are present. And Cl minus, if we consider, atomic number is 17, but electrons are 18. And S minus 2, if we consider, atomic number is 16, but electrons are 18. And Ca plus 2, if you consider, atomic number is 20, but electrons are 18. So this is the way we can identify which is more in size, which is less in size, just by doing the calculation. But out of this, without doing this calculation also, you can simply answer the question that these are all isoelectronic species. So among the isoelectronic species, when positive charge increases, size decreases. When the negative charge increases, size increases. So that's a simple thing. So here negative ions will have the more size than the positive ions and neutral ions first. So S minus 2 is having the highest negative charge, so that S minus 2 size is more than the next Cl minus. Next one, neutral atoms comes, that is argon, which is more in size than the next positive ions. Positive ion size is less. So among the positive ions, here positive charge is less, here more. So K plus is bigger in size compared to the Ca plus 2. So this is the order to be followed. So option C is correct. The next question is 8th question. Which is correct in the following? The radius of chlorine atom is given. Chlorine atom 0.99 angstroms, and similarly Cl plus ion is given as 1.54 angstroms. So here one thing to be remember that in a particular for a particular atom, negative ion, for example, if you take an X atom, so X minus size is more than its parent atom, and X is bigger in size than its cation. So anion size is always more than the neutral atom, and neutral atom size is always more than the cation. The reason is, in the case of the anion, it is found by the gaining of electrons or by the addition of electrons. When the number of electrons increases, size increases. And cation is found by the loss of electrons. So when the electrons are lost, nuclear attraction power over the last orbits increases, so that obviously size decreases. So this is the reason why we have to follow this particular pattern. But here they had given the Cl plus size is more than the Cl size, neutral atom, so which is incorrect. Next one is radius of chlorine atom is 0.99 angstroms. Similarly, next option they had given, that is chlorine 0.99 angstroms, and while that of sodium atom is given as 1.54 angstroms. Then we have to see these particular elements whether they belong to the same period or not. If you see the sodium belongs to the second period. Its atomic number is 11, electronic configuration 1s2, 2s2, 2p6, 3s1. Sorry, sodium belongs to the third period. Its electronic configuration is this one. And chlorine, if you see, atomic number is 17, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. So both of these atoms belong to the same period. So along the period from left to right in the periodic table, atomic size decreases. So sodium size, no doubt it is more than the chlorine atom. So that option B is correct. Let us solve the question number 9. Which oxide of nitrogen is isoelectronic with carbon dioxide? So first of all, let us try to count the number of electrons present in the carbon dioxide. Carbon atomic number 6, each oxygen 8 plus 8, 16. So 16 plus 6 means there are 22 electrons present in the carbon dioxide. Okay. So now let's try to calculate the number of electrons present in each and every option given here. NO2. Nitrogen atomic number is 7 and here it is 16. So one bigger, so that they will not have the same number of electrons. And NO, 7 plus 8, so no number of electrons are equal. N2O, if you see, this is 7 plus 7, 14 plus 8. This is equals to 22 electrons. So N2O and CO2 both are having the same number of electrons. Hence option C is right. Now let's try to solve the question number 10. The ionization potential of sodium would be numerically the same as. So first of all, let us see the definitions of electron affinity and ionization potential. See, you take an atom and try to remove one electron. So to remove one electron, you need to provide some amount of energy to the atom. So the energy what you are providing to the atom to remove the last electron is called the ionization energy or ionization potential. Complete definition I am not giving, only normal definition I am giving. So after removal of electron, it becomes Na plus. And whenever you are adding one electron to this Na plus, whenever electrons are added to either neutral atom or cation, energy will be released. The energy released during the addition of electron is called the electron affinity. So in the earlier case, if x kilojoules of energy you are utilized, then automatically x kilojoules of energy will be released. So that's why ionization potential of neutral atom is equals to the electron affinity of its cation. This is the formula. So here the ionization potential of the neutral atom is equals to the electron affinity of its cation. Cation of Na is Na plus. So that option A is correct. The question number 11 is, what should be the atomic number of the next halogen if discovered in the future? Let's try to write down the halogen atoms here. Fluorine, bromine, iodine, astatine, and we don't know what element they are given. Some, let us take it as some X, Y, Z. Some element is there. So its atomic number we know that 9, and we have to follow the same pattern. 8, 18, 18, 32 and 32. So this is the pattern we need to follow. So just add 8 to the 9, you will get the next element atomic number, chlorine as 17. and add both of these, you will get the next element of bromine atomic number 35, and add both of these, you will get the next element iodine atomic number as 53, and add these, you will get the 85, and add both of these, you will get the next element atomic number as 117. So option C is correct. Question number 12. The electronic configurations for some neutral atoms are given below. Which of these is expected to have the highest second ionization enthalpy? Highest second ionization enthalpy in this sense, the particular atom must have the only one electron in its last orbit. Then only highest second ionization potential is possible, because sudden jump is possible. Here 2 electrons are there, not possible. Here 2 plus 2, 4 electrons are there, not possible. Here 3 plus 2, 5 electrons are there, not possible. Here only 1 electron is there, next orbital change. Hence option B is correct. Let's solve the next question. 13. The law of triads is applicable to. It is applicable to chlorine, bromine and iodine. And 14th one is the law of triads is not applicable to. We have to search all this. So among this is not applicable to the sodium, potassium and rubidium. These are just conceptual questions which are to be followed from the given book. So next question is 15. So a given compound A2, there is a compound A2, means there is a bonds between the two A atoms. It may be single bond or double bond. Let it be some A2 molecule is there, whose total distance between the two A atoms is equals to 1.4 angstroms. The atomic radius of the atom is, so total distance is 1.4. The radius of single atom means you have to take the half of the internuclear distance. So just divide by 2, you get the 0.7 angstroms. Hence option A is correct. Let's try to solve the question number 16. In compound AB, electronegativity difference between the A and B is 1.9. Atomic radius of A and B are 4 and 2 angstroms respectively. The distance between A and B means DAB is. So they had given the different values, and the molecule is found between the two elements of different electronegativity. In such cases, the formula is the distance between the two atoms in a molecule which are formed by the different electronegative elements is the formula radius of A atom plus radius of B atom minus 0.09 into delta x. This delta x means it is nothing but the difference in electronegativity. Okay, so DAB is equals to radius of the A atom is given, that is A is 4 angstroms, B is 2 angstroms. So 4 plus 2 angstroms minus of 0.09 into difference in electronegativity. So difference in electronegativity directly they mentioned as 1.9. So by substituting all these values, we get the DAB answer as 5.82 angstroms. So option B is correct. So let's solve the question number 17. Ionization energy of only one hydrogen atom is given. Single hydrogen atom ionization energy is given as 2.18 into 10 power minus 18 joules. And ionization energy of the hydrogen atom in kilojoule per mole means per mole of the atoms how much ionization energy is required. So one atom is this much value. 1 mole means multiply with 1 mole value into 6.022 into 10 power 23 joules it will be. But you want to get in the kilojoules. 1 joule equals to 10 power minus 3 kilojoules. So 2.18 into 10 power minus 18 into 6.022 into 10 power 23 into 10 power minus 3 kilojoules. So that if you solve all these, the answer will be 1310 kilojoules per mole. So option here it is B option is correct. Next 18th question is Among the elements calcium, magnesium, phosphorus, chlorine, the order of increasing atomic radii is. So the concept here is generally atomic size decreases along the period and atomic size increases down the group. So in down the group, atomic size increases, along the period atomic size decreases. So first of all, let's write down these elements in the periods and groups. So if you write down here, magnesium atomic number is 12. Next one, phosphorus, which is 15, chlorine, which is 17. All these belongs to the same period. So along the period, atomic size decreases. So magnesium is larger in size than the phosphorus, phosphorus is larger in size than the chlorine. But when it comes to the calcium, calcium is 20 atomic number. It is just placed below of the magnesium. So calcium is larger in size than the magnesium. So all over it will become calcium is more than the magnesium, more than the phosphorus, more than the chlorine. So this has to be followed. But here they had given the increasing order, we have written the decreasing order. So just write down the chlorine less than, phosphorus less than, magnesium less than the calcium. So the 18th one is, if you see, chlorine, phosphorus, magnesium and calcium, option C is correct. 19th question is, which of the following order is correct for acidic property? So we must understand that the acidic character of the hydrides increases in the period for non-metals. So as acidic character, for example, if you take CH4, NH3, H2O and HF like this, hydrofluoric acid is stronger acid than H2O, which is stronger acid than ammonia, which is stronger acid than CH4. So among the non-metals, the hydrides acidic nature increases. So that's the reason why if you check here, silicon, phosphorus and sulfur, silicon, phosphorus and sulfur. Silicon atomic number 14, phosphorus is 15, sulfur is 16. So they belongs to the same period and their hydrides acidic nature also increases like this. So that H2S is more acidic nature than the pH3, which is more than the SiH4. So option D is correct. Let's solve the question number 20. The ionic radius of chromium is minimum in which of the following compounds? So minimum means, just you see, for any metal or element, when the positive charge increases, then the size decreases, as I said in one of our questions. So just you see in CrF3, chromium oxidation state is +3. In CrCl3, chromium oxidation state is +3. And in Cr2O3, chromium oxidation state is +3. And here chromium oxidation state is +6. So that higher the positive charge, minimum the radius. So option D is correct. Students, hope you have understood my concept. So before solving these questions, I request you first you go through the concepts what they are taught in the college. Then you follow these multiple choice questions, because here concept we cannot explain much, as these are the solving of only multiple choice questions. So hope you understand. If you understand, like and share these videos and subscribe the video. Thank you.